Thank you, Nathan. So, good evening, everyone, ladies and gentlemen. Yeah, it's for the camera. My name is Michalis Kanelis. This is my colleague Tuce Tosunuslu. And we are going to talk to you about an alternative energy generator for the built environment, the luminescent solar concentrator, or in short, the LSC. Uh, we are all part of Kikino Energy, so everybody's aware about of the energy problem. Buildings account for 40% of global energy use, but what maybe some people don't know is that 16% of the worldwide energy consumption is due to the insufficient control of sunlight, mostly in buildings, but in general in the built environment. And when you are talking about energy cost, you go either the passive way or the active way by generating electricity, renewable energy. First option when you want to go the active way is photovoltaics. Everybody is aware of PV systems. Everybody is aware that the efficiencies are going up and the price is going down. So, of course, it's a really interesting and cheap solution. But we are talking about the built environment. So when it's the place that people live in. They work, they socialize, they interact with everyone. So human psychology is really important. And one of the factors that affects human psychology is in the surroundings is the color. And I think everybody would agree that they would prefer to live in a colorful, cheerful, and vibrant environment like the one on the left than something that is less colorful on the right. And when people try to integrate PV systems into the built environment, BIPV systems, then experience and research has shown that, yeah, the result is not so appealing for the human eye. Constructions don't look so lively. It doesn't offer too much color. So in the end, the aesthetic result, it's not much of an upgrade, even though the energy generation is quite significant. What if buildings like the ones you see here, colorful ones, colorful facades, glazing in different colors, blue, yellow, green, whatever, they could also generate renewable energy. And the answer to that is the luminescent solar concentrators. It's basically, I got some samples here, you can see. The working principle of luminescent solar concentrators, no, Tucha, I need one. Uh, is plastic that contains fluorescent dye. The fluorescent dye, as you see here, it can absorb and emit light at certain wavelengths. And when the light is emitted, then it travels inside the waveguide, and it is emitted through the side. As you see here, there's quite some light concentration on the side. In the red one, it's more apparent. And this is the place that we put the solar cell in a strip. It has to be very thin. And therefore, the solar cell always sees light, and you get renewable energy generation. This technology is fairly new, even though very mature, but it has certain advantages compared to the traditional photovoltaic cells. For one, as I said, it's plastic, so it's inexpensive. For two, it can be of any color. I have three colors here. You saw the yellow one, the red one, the blue one. There is more. There is like violet, green, even transparent if you want. And so they can be cut to any shape, and they are flexible. So this means that when you want to make a really fancy construction, it is possible. They are transparent, as you see. So this is of some added value in the built environment. It doesn't obstruct the view. And also they're lightweight. So you see, and also very sturdy. So it's a very promising solution. But the most important advantage when it comparing to the PV systems is that when we have indirect radiation, so basically clouds, the drop in their performance is not as big as the traditional photovoltaic systems. Even though the advantages are big, adaptability has a great cost. And the biggest boundary right now of this technology is their low efficiency. In research, efficiencies have gone up to 7% and 8%. This is more or less the efficiencies that organic solar cells are having, but as photovoltaics were developed many years ago, uh, then there is a lot of room for improvement for the LSCs. And when we are talking about adaptation, it's about thinking whether we want to have a landscape that looks gray like this, or we would like to transport it into something like this. Highways and railways, for example, that would look nicer, facades that would also look nicer. And in order to learn more about this, this is a project that I'm currently working with, Heijmans. It's a Dutch construction company. We have set up those two demonstrators in Den Bosch, in the Netherlands. It's essentially a living lab. We are testing, as you see, two colors of LSCs. The top one is the red one, the one that you have here. The one underneath is orange, orange/yellow. And in the bottom, it's two different technologies of traditional photovoltaics in order to have a reference. We believe that it's a really great opportunity to find out about the true potential of this technology and go one step further.
Thank you, Mihalis. Yeah, so Mihalis introduced you LSC and mentioned the technological developments going on, the efficiency and so on. But in order to commercialize this device, basically, we need to do more research about the design and presentation aspects of it as well. So this is what I'm doing in the same company, Heijmans. I'm looking into other application areas rather than the noise barrier. So my aim is to find maybe another application area that's also a good business case. And I am using a methodology for the idea I used, a methodology to generate ideas together with the employees of Heijmans, the SEPSI trainees, also some students from TUE and external designers from Design Academy, so that we could co-create and find out some ideas that are worth producing with LSC. For that, I also conducted a small questionnaire. I did also looked into the existing examples of colored glazing, which you've seen one slide from Mihalis, because color in design is not something new. So actually that I want to show you a few examples that are already there and that can be basically substituted by LSC. So color is everywhere, it's not something new. Even in architecture, it has many different reasons to use. You might like to emphasize, let's say, a shape of a building, or you would like to evoke some emotions at certain points in urban design, whatsoever, but you have it. So this is one of those examples from Montreal. It's a public building, a convention and exhibition center, and in the existing it was an existing building, but they renovated it and added these colored extension, the colored facade. So if you just imagine, you could have 3% electricity generation from one color and 2% from the other and 7% from the other one. So you could actually generate electricity right on the spot, and some people could plug their phones and charge their phones right there. Some other example, and again a public use for a retail space in Melbourne, and again you could see how this colored shading are actually creating these nice colorful areas. So you could just substitute these just like that these elements by LSC and generate electricity, some electricity. This is a transportation waiting area, an example from the Netherlands. As you see, the architects have already chosen this orange color to give identity to this place, to orient people, create a landmark. And it is also possible to light the light bulbs inside this little structure if they were from LSC. And not only for public buildings, it could also be used for residential, as in the case here in France. The designer already wanted to use these different colors for the balustrades, for the balconies, and vertical shading. So we thought there's potential, But we wanted to also ask some other people, so I conducted this small survey, online survey, and asked the opinions of people who participated about the color of LSC, about the different applications, the application areas. And I had 82 respondents. They were quite young, basically from architecture and engineering background. I think this is interesting. 52 of them haven't heard of LSC before. But even though they haven't heard of it, 85% of the respondents thought that yes, LSC could help increase, it could be integrated in the built environment actually. So another co-creation methodology I've used was making these workshops. I have done 2 workshops with the employees of Heimans and also the SEPSI students. I would like to ask you, have you heard of LSC before? Could you raise your hands if you have heard of it before? Yeah, because we are from the University TUE, Technical University of Eindhoven, and there is the Chemical Engineering Department and the Built Environment working on LSC, so we know about it, but the rest of the world has no idea. So it's quite interesting also to get some ideas from people who doesn't know. But this co-creation was basically conducted with people who has an idea of it, the aim was to actually to find out what kind of components or objects you could design with this material for the built environment. And we grouped we generated more than 100 ideas, and we grouped them here. Basically, I will read through shading, self-sustainable lighting and types of lighting for outdoor area, transportation, waiting areas, signs, signage, this sort of information boards, any sort of glazing for the building envelope, urban solar art objects, lighting with the edges. This is interesting because as you could see, you don't have to maybe generate electricity from the edges, but you could also use it as lighting. Or any other types of public uses for such as built-in games like tiles in urban areas, or temporary furniture for activities, and as we mentioned, barriers as well. Of course, this was the diverging phase, and now at the end we had to select an idea for the company maybe, and according to our co-creation and co-creative studies, it was clear that actually you can do anything with this material, but what is worth doing it? So we also looked into different, we looked into the expertise of the company and what their interests are for the future. So since this is an infrastructure and construction company, we focused more on the things that are interesting for them. We are still looking into this. And of course, they want to have a large impact without spending a lot of money on it. We are currently looking into this, and I can't share all the details, keeping it for myself, but whatever we choose to pick and design, of course, we should have a future vision to make it really, what do we want to achieve at the end? So we said, okay, we would like to achieve premium LSC products with an established business, and they would serve also the well-being of the environment. And we need a roadmap to reach this goal. And we identified also these 4 action points: market entry, business development, knowledge networks, and research. They would help us probably reach this goal at the end. We know that it is a complex problem to find, because it's a technology, this is still in development technologically. So to find the final goal, of course, there are several ways to go, so it takes time. But in conclusion, I would like to say that we believe that energy problem is not yeah, it's something you can solve with only one solution. But LSC being colorful, flexible, and so on, might be a part of the energy problem that we are facing right now. So we think let's color our future. So this is the end of our presentation.
Thank you very much, Michaelis and Dr. Do we have questions? Cool. Okay, Alesia is going to be looking after the microphone, so she'll be taking it to you and back to the speakers.
Yeah, because does it work?
Yeah, okay. Yeah, I understand it's very confusing. It's just for the camera. So these talks are being filmed, and in order that people who watch it later will be able to understand, they need the audio.
So thanks for the nice presentation. When you were saying the advantages, well, you were saying about the traditional photovoltaics, but when you were saying the advantages, it's like hearing the organic photovoltaic advantages. I think when you make like the economic study, you should see how they compare, because with organic photovoltaics, you can actually make all the colors as well. You can also make infrared absorbers that they will be completely transparent. The efficiency, the current record is close to, it's above 12%, so it doesn't sound that bad anymore. Of course, it's a device that is like 10 square millimeters, but in large scale, maybe it will be like 8% with these new materials. So I think it will be really interesting, because in those cases, you don't have the heat up problem that I talked with Mike yesterday, and it will just be the whole surface. There was an example already installed in the German pavilion in the World Fair in Milan. And there are, I don't know, I think it could be a really nice comparison to see if you could really attack that market, because there are like 4 companies that are already close to production in organic photovoltaics in Europe.
Yeah, thanks, Joshua. I don't doubt that it's a different technology. I don't know the potential of the organic solar cells. I guess you know more about it. I know a bit more about LSCs. And yeah, when it comes to colors, yeah, I didn't know that organic solar cells could be colorful. And also, as you said, the efficiencies go 12%, but it's a small piece. But what happens when you scale up? Yeah, this is also what we want to find out. It's a technology with potential. It's an alternative, as I said. Photovoltaics are there. They will continue being there. But for the advantages that I mentioned, yeah, mainly they are against the trend, which is the silicon solar cells. Organic solar cells, I don't think they have a big share in the market. Correct me if I'm wrong. Compared to the silicon, yeah, but compared to the silicon solar cells, I seriously doubt they have the same share. Yeah, but
Just saying that they are also going for special markets. So they are also going for phone, for example, phones. They are going for the building integrated because of this color thing. They can also be printed in flexible materials. So that's why I said, I'm just saying, I know that this is a different technology that can also be used for the noise material, so it's really nice. But it's just something that you should take into account, because it will be a really nice comparison to know. Even if you want, you can ask me. And
yeah, sure. But the thing is, I'm sure about it. Research on LSCs is really minimal. I mean, there is like really few things that we know. I suppose, and I think I know, that organic solar cells and in general solar cells have less, let's say, unconnected dots than LSCs. So yeah, it's something for the future. There also, for the technical aspects, there's so many things that we don't know yet. As I told you, research papers have shown this efficiency 7 and 8%, but this is also in small scale. It's like, I think 5 by 5. I think I read, if I remember correctly from the research papers, and this is why the noise barrier is the first ever large scale measurement that it's ever done. It has never been before a panel so big and being measured. So it's, for this technology, it's something for the future to realize its true potential. Currently, as I told you, it's work in progress. It's research.
I think both of them are for the future. So that's why
I have two questions. First question, starting with vandalism. Is this material like hard enough, for example, to be protective against vandalism? Yes. Yeah. That you maybe answer this question first, or like okay. The second one, and the do you have any idea on prices yet? Like how much it would cost approximately per square meter? Or?
For vandalism, in theory, it's plastic, so it's kind of sturdy. But yeah, we don't know how much attention it attracts. If it actually makes people want to attack them, and yeah, it's also part of the experiment. It's not only a technical experiment; it's also a social experiment. We want to see if maybe it's distracting for the drivers. Maybe the drivers see the red color, I don't know, they want to crash or what. This is something that it's unknown. We want to know. As for the second part, I really have no answer for that because it's not commercialized. So if it proves to be a business case and it gets commercial, then prices will go. It won't have to be, let's say, one order that you are making and you order just one piece. It will be a lot lower than asking for just one piece. So yeah, no, for now, no. I really have no answer to. I don't know.
From the technological point of view, you said that you are comparing with the conventional solar PV panels as a reference. From the business point of view, what's your reference? When do you think it's a feasible business? Are you comparing with this conventional solar, or there are some other standards that some other benchmarks that you have set?
I said that on the living lab, on the noise barrier, we want just to see how different it is. But yeah, on the a traditional noise barrier just blocks the noise and nothing more. But there are also not so many projects with photovoltaics. So it's also something that we want to find out. In terms of business, how they compare. If I have a reference, not yet. It's also part of the research to find what is the, let's say, business model and the business approach behind, the LSC, how it is going to be done. It's just an unknown.
And also the aim is not to compete PV because it has to exist by its own, and it will. But LSC is a different value, as you said. It can be maybe comparable with colored organic solar cells. It's similar market, but the business value, as you said, in this one is that it is cheap. Actually, we can't say much about the prices, but it is just plastic. It doesn't contain, and also it's recyclable. If you think about the long term, it's organic dyes inside, so it's environment friendly. I know when we say plastic, we all think that it's not, but it's recyclable. It has a long lifespan in that sense. So. There's some issues that it's better than PV like that.
To continue on that, you said it's cheaper. Is it cheaper with the technology, or it's just the plastic that you are saying is cheaper?
Yeah, plastic is cheaper.
Okay, but
You need just solar cells.
But as a system, we don't know yet because it's not commercial. As I told you, as a system, we don't know yet. If it becomes commercial, how it is going to compare in terms of price.
But if the PV prices decrease, the price of LSC will also decrease because it's dependent somehow. You are dependent on the solar cells. So.
Okay, I have two questions. One is about the efficiency. You just said that you should not compare with the typical solar cells. And looking at your application, it's mostly about lighting and stuff. In that case, you are not converting it into electricity. So you can picture yourself as much more efficient than 7%. So why do you have to say it is less efficient when you are not converting it into electricity? So, is the question clear? And should I say? Yeah, the second question. Uh, I can see that there are different colors, and physics says whichever is the color we can see is reflected and not absorbed. So, is there a difference between efficiency of different colors, and is there equal potential for all the colors?
Ask you to remind me. The first one was about why to compare. The yeah, can I have a plate, please? Yeah. Anyway, for example, this one. It can be used for lighting because it concentrates light, but when you attach the solar cell strip on the side, then this light will be converted into renewable energy on the solar cell. That's the principle. Depends on what you want to do. It's you can, you can. I agree. And the second one? And the second one was? About the colors. Yeah. There is not so many options in colors yet. For example, I have here 3 samples because these are the ones that I could find in acceptable size to bring here. As I said, it's kind of unknown. The red dye, the red panel is in theory the best one in terms of light on the side and everything. But it's also under research to how to make it better, how to make it, let's say, more efficient, how to lose less light and transport more to the side. I would really like to have the same conversation in like 10 years. Hopefully that we will know more. Research will have produced more results. Maybe more applications will be out there, not only for, let's say, noise barriers, but for other applications. And it's not only for generating electricity, it might be also, electricity might be just an added value. It can also be for the design. It can also be for the color. That's a matter of how you place your business. I think it's enough, right?
I have a very short question. Basically, when I looked at this panel, it like the red one was lightning with the red light. But when I put it on my jeans, it wasn't red, it was white light. So what color of light is it actually? Like if we switch off the light and I want to read a book, will it be the paper, yeah, will it be red or white? Like, you know what I mean? What is the color of this light in reality? No, it's white. Or it's red. Because we tried it together and I'm not sure, yeah?
If you look this way and you get the red shade here on my palm, but if you try to reflect this way and it reflects white light here, I mean concentrates white light here, it seems to be an illusion.
I have to see this because I really don't. Oh, no, please show.
Yeah, it's like, see,
Now you
this
can.
is red, yeah?
It's red.
Yeah.
Now, and you turn it around, and
And there is not red here.
there is no red. I don't know where the light is.
Yeah, it's the shadowing effect. This is shadow.
No red light.
Look. Yeah, the idea of the LSC. Yeah, the idea of the LSC is that light falls here, and light gets emitted from here.
Yeah.
But if you turn it like that, then the light that falls here cannot travel all the way down.
Oh, it cannot.
No, it will come out from that side.
You can just put a spectrometer in front of it.
Or that. Yeah.
Thank you. Hello?
No, it's okay, it's okay.
Okay. Yeah, I have several questions. First is I have to confirm that they're asking that you are not transferring the solar energy to be electricity. What does that mean? Because for me, if you put the solar cell, then it's for lighting. I was not quite clear about this. Can you explain me again? I really didn't understand. Yeah, I mean, yeah, but why they are saying you are not transferring it?
Yeah, maybe some more clarification. This thing by itself, it generates nothing. The only thing that it does is that it concentrates the light on the side, and by applying a solar cell on the side, the solar cell sees the light, so it does what it does when you face it against the sun. Yes, this thing is just, it's the plastic, it's this one. It's another thing, the LSC, and it's another thing, the system that you also attach the photovoltaic cell, which actually converts the light emission from the side into renewable electricity.
The second is you said in your presentation that it is flexible. It's also possible to be flexible. Like with a flexible curve, you can direct the light all through. Okay.
Yeah, but the research is very limited.
Okay. Okay. Maybe I ask all. The another is with this project you have already done. Did you just apply this plastic, or you also applied with some solar cell? And do you have some like analysis data as outcome of this application or no?
Yeah, it is flexible. Okay, it gets bent, it's sturdy and everything. Of course, it breaks. There's a breaking point. It's not elastic. So yeah, it can be used for making different shapes. As for the second one, yeah, no, the project has been running only for some months, so there is no concentrated data to publish yet. Hopefully, within 1 or 2 years. Yes, it's with PV. Yeah, on the side, the plates that you saw. No, that I cannot disclose. Sorry. But yeah, there is. Yeah, in theory, you can use anything that converts light into electricity. But yeah, here there are certain solar cell strips applied, and this is how we are measuring the technology. And also the other two panels, they have different, let's say, regular solar cell solar cells, and we just want to see, you know, a comparison. What does it mean?
When you apply this, how to say, I would say module series, because I think if you want to transfer the energy, you need other components. For example, you need inverters, energy storage. You do it in a, how to say, decentralized way for every panel, every one, or you do it in a, how to say, systematical way with a whole holistic approach.
Yeah, no, other than that, the principles that apply for transferring the energy are the same as the traditional solar cells. Inverters, cables, everything. Now, about that, I have no answer because we just have those two, and we are measuring. It's not connected to the grid. When at some point in the future, hopefully, there is a bigger project, this is something to find out. But I simply have no answer because there isn't any yet.
Just maybe an idea, because using it on the side like of the road, you know, as a noise barrier, I think an interesting added value that could potentially work. I don't know if it works with that technology, but could be something that purifies air. You know, nowadays you have like coatings that you can just spray on, like titanium oxide or something, and that purifies air. So maybe you could, in this, it could be a thing to check if it's easily to put on, you know, and then you have an added value. You have just plastic, generates electricity and purifies air. So maybe.
Another comment to add on, there's now being developed stacked solar cells. So if you can look into them, like instead of one thin film, stacked solar thin films. That might increase because there have been, in normal solar PV panels, there have been reported increase of efficiencies from 15 to almost 24, and in research laboratories up to 30%. So if you can see into them.
Okay, thank you very much, everyone. Yeah, thank you both. That was a really, really interesting talk. It sounds like a very exciting new technology. Lots of enormous applications. Really, really interesting. Thank you both. I'm just gonna have to make an announcement for the. Yeah. So, guys, if you could just quickly, I have some exciting stuff to talk about. Maybe. Okay, so the fun part that was promised for tonight. Lots of people have been wondering what the surprise is for the event. We have dinner tonight, and the surprise is that we got 3 hours of free drinks, soft drinks, wine, and beer, all you want, for 3 hours of dinner. Pretty cool, right? Woo! We thought that different people would like to do different things tonight, so we've done some research, and if you would like to stay around here or go to town, then there are a few options. So if you'd like to stay in the hotel, of course, you have the pool. Remember, it closes at 11. But then near here, there's like an Irish pub not too far in Spandau, and another bar called Charlotte. Yeah. If you need any details, you can Google Maps or ask one of the organizers. If anyone's up for going to town, who would be up for going to Berlin tonight, just to see how many people? Yeah, okay, cool. That's cool, okay, that's good. So we checked, it's about 45 minutes to an hour if you go by public transport to get to Berlin. We're thinking probably Friedrichshain or Kreuzberg, which are two cool districts. Lots of nice bars and clubs and restaurants and stuff. We have some little tips for going out in Berlin. You probably heard the nightlife is really good here. The tips for getting into clubs are go in small groups, and if possible, take girls and guys together, because apparently that helps. Yeah. Cool. So thank you very much, everyone. And dinner is, well, it's from now. So enjoy that. Also, if you want a drink before you go, there's some water and stuff at the back. I think we're probably finishing a bit before the other talks. So either use that to wait for your friends and enjoy a drink, or just get to the food as soon as possible. Up to you. Thank you.